Good morning, or indeed good afternoon, depending on where you are, and welcome to DCD Critical Power, the global broadcast series on 7x24 uptime and availability. In this latest series, we will be tackling the challenges and decisions required for all the power architectures and infrastructure in the data center, including a deep dive into the latest advances in power management, backup and generators, right down to the chip-level innovations and virtualized power. This broadcast is part of DCD's always-on content program for the data center, cloud and edge infrastructure industry, and we've pulled together a powerful lineup of industry experts to share their insight on this topic. I'd like to take this opportunity to thank all of them for their contributions. And in front of you see a glimpse of our upcoming broadcast schedule, where we'll be looking in depth at regional data center markets, including North America, Asia Pacific, Africa, and Europe. Full details of the 2021 calendar are available at datacenterdynamics.com, where you can subscribe to stream any of the broadcasts now for free. And entries for the DCD Global Awards are now open. We have a number of new updated categories for this year, and many of our winners over the years have involved innovative critical power architectures and infrastructure solutions. So take a look at the categories in the awards website link in the resource box on your screen and start planning your entry. And best of all, everything's recorded, so you don't have to miss a thing. You can watch all of our broadcasts whenever, wherever you like. Just look at the On-Demand tab on our website's top navigation bar. Right, we're almost there. Before I introduce the next session, though, I'd like to tell you a little bit about the functionality we built into the broadcast experience. We have a Q&A widget that you'll see on your screen there in front of you. You can use that live, and the moderators will try to include your questions to the speaker in the Q&A section at the end. If they don't have time, though, it will be forwarded on to the speakers. In the resources widget, you'll find useful downloads and links relevant to this session. You can also find the full live stream schedule here too. On the screen, you'll also see a link through to the DCD Connect platform, where you can network with all the speakers, delegates, and our sponsors, so don't miss out. You'll also see a link to our DCD Pulse survey on the console. Your input will help to inform the industry about power infrastructure trends. So please take 5 minutes to fill it in, and you could win $250 of Amazon vouchers as a thank you. Last but not least, many of our sessions have roundtables that follow on from them. They're a great chance to talk with the speakers and your fellow attendees in a more relaxed environment and share your views. So without further ado, let's get on to the next episode. It's a panel discussion. What's the answer to the power over provision data center, and what's the bigger opportunity? On the panel, we'll dive into utilization technologies, how they can liberate unused power, and what sustainability-focused possibilities are unlocked. Your panelists for today are Suresh Pichai, Director of Innovation and Development at Equinix, Ed Ansett, Co-founder and Chairman i3 Solutions Group, Rish Gatikar, Senior Program Management at the Electric Power Research Institute, and moderating the session today is Daniel Bizo, Research Director at the Uptime Institute, who's covered the business and technology of enterprise IT and data center infrastructure in various roles for 15 years, including a decade as an industry analyst and advisor. So pretty capable hands. And with that, Daniel, over to you.
Thank you, Chris. Good afternoon, everyone. So first of all, thank you very much for joining today's session. And before we go any further, I think it would make sense for the benefit of the audience, to do a round of, introductions. So maybe in the order of the slides, could you gentlemen, maybe, say a few words about your companies and about your role at your organization. So Suresh, could you please kick us off?
Yeah, Suresh Pichai, Equinix. We are premier global co-location facility. We call ourselves a digital infrastructure company. I've been here 13 plus years, and I've had a fairly long stint at Intel and Jacobs Engineering. Been focused on a lot of new developments in the data center world, whether it be liquid cooling, energy storage, and then microgrids. Some of that are coming into reality. Some of them are still in the lab, like software-defined power. Let me pass it on to Ed.
Okay, thanks, Suresh. Ed Ansett, I'm the founder of i3 Solutions Group. We are a company of consulting engineers that specialize solely in data center infrastructure, specifically power, cooling, and controls. My personal area of interest is power system reliability, and these days, new technologies associated with greenhouse gas reduction applied to data centers.
Right. I'm Rish Ketikar. I'm with Electric Power Research Institute. I'm a senior program manager here. I lead the program called Information and Communication Technology for Electric Industry. EPRIN itself is a nonprofit research organization that focuses on anything that relates to electricity for the industry. My work has been primarily focused on looking at the areas of developing technology solutions for grid integration, one of the area I work extensively for the last 21 years. And that, 2/3 of that, 14 years of that spans at Lawrence Berkeley National Laboratory, which is the U.S. Department of Energy, that is focusing on looking at demand flexibility or grid flexibility and understanding how demand response and grid flexibility can be a key resource, not just to the data center operators, but also to the electric grid operators. And that's what I'll be focusing on today. And it's good to be here. Thank you.
Thank you, Rish. Okay, so my role really here is to set the scene. So why you are here today? So power provisioning is part of the bigger topic of capacity management, capacity planning, and forecasting. And at the Uptime Institute, based on our discussions with operators and also based on the surveys, the regular surveys we run, on the sector. What we see is that capacity forecasting and capacity planning remains one of the biggest challenges for operators. This is not us, saying that. This is really what operators are telling us. So capacity planning / forecasting, tends to receive the highest number of responses when we ask operators what they thought was their bigger challenge, business-wise, running the data center. And one thing I wanted to point out, I don't have multiple slides, in the interest of time, but just saying a few words about some data points. So when we ask end users, enterprises, end user businesses about their capacity requirements across their own data centers, so on premises, across leased facilities such as Equinix and others, or clouds, what we see interestingly is that many of them, and on balance, the sector as a whole seems to be still growing across all these three major venues, if you like. And so that means that these capacity planning and forecasting challenges are not really diminishing or going away anytime soon. What we see is that they are literally getting bigger because enterprises are looking at more and more capacity, and also because of this dynamism across multiple venues, that as you can imagine, adds, and probably you experience as yourselves, adds further complexity. So the view you have on the slide is that at the same time, when people add and upgrade their IT, they also find it challenging, often when it comes to supporting, the power delivery or the cooling delivery mostly. So what this slide says is that compared to 2018, 3 years later this year, it has become a bigger problem, making sure that you can serve your latest IT systems with sufficient power and cooling. So this is interesting. It's almost like a contradiction in itself. When we also look at other data points, which say that people do refresh partly to reduce their footprint, to compress the total amounts of power and cooling required at their facilities or at third-party facilities. Yet at the same time, they report this sort of issue of straining the resources as they go through these refresh cycles and re-platforming their IT infrastructure. So the topic of today, of course, is over-provisioning of capacity, over-provisioning of power, mostly the topic of the panel, and that is a key source of inefficiency. But before we go any further, probably it makes sense to just maybe pause there and define the problem. So this is really a question to the panel. So I'm opening up now, gentlemen, that maybe just share a couple of high-level thoughts why from your point of view we should be focusing on over provisioning. Why do you think it's a problem that deserves the attention of not just this panel but the audience today?
Okay, this is Suresh Pichai. From a data center point of view, power costs quite a lot in terms of capital. You have utility power with the infrastructure associated with it. You have generators, UPS. So the more megawatts you provision, the more you spend. So if you spend the money, you want to use it. And there are problems preventing you from using it. Number one, data centers are designed on the basis of an assumption for an average power density, kilowatts per cabinet. It never works out. There's a variation. And the power is segmented into blocks and used within blocks in data halls. There are different so-called topologies, but regardless, it's segmented. A data center could be segmented many ways. And then within each of the segment, there could be an imbalance in terms of what is the demand and what is provision. So the whole thing is made worse by the segmentation process. And then because of the variation in the densities, you end up with either space being stranded or power being stranded. Power stranding is really a problem from a capital inefficiency point of view. So let me hand it over to the other panelists to share their viewpoints.
Thanks, Suresh.
I agree.
Who would like to go next? Is that Ed?
Exactly. Suresh is absolutely correct. I mean, fundamentally, the fundamental problem with over-provisioning is it's a huge cost burden, arguably an unnecessary cost burden. But nonetheless, it is endemic throughout the data center industry with very few exceptions. So really, the issue really now is what can be done about it, and there are quite a few things that can be done. Which doesn't suddenly mean the way that the data centers are designed need to change overnight, but there are some solutions which we're going to talk about as a group later on in this session.
Rish, was there anything you would like to add?
Sure, absolutely. And those were great leads from both the earlier panelists. In my work, as I said, focus a lot on grid integration and linking, data centers with the electric grid. Part of the benefit that we look at over provisioning is also the benefit that you would get from improving the grid reliability and reducing the amount of grid infrastructure you need, because the grid is not designed to not just meet the needs of how much power a data center uses, but how much potential power a data center may use from the reliability perspective, and that adds cost, etc. So there's a huge driver or ripple effect of over-provisioning that could be looked at. But also the important thing is, there are advanced strategies that can be used, that goes beyond redundancy in power provisioning that can deliver great benefits, including providing for drawing on services outside the data center facility that exist, whether it's for, looking for reliability reasons, availability reasons, and resiliency reasons. So there's a tremendous potential to start thinking creatively on what data centers can do to alleviate or even eliminate the over-provisioning.
Mm-hmm, mm-hmm. Very good. Thank you for those thoughts. May I just, play the devil's advocate and maybe ask, a challenge question. So I understand the arguments that, it's bad practice to overbuild or build a data center and then, not utilize its capacity. But that's sort of, you could argue from the point of view of a business that's, spilled milk under the bridge. So that's some costs that they cannot really recover. So is that really is it something that creates an operational or business problem, you think, for operators or customers that they are not correctly assessing their capacity requirements? So what are your thoughts on for those people? So what are your thoughts for those people who might think, okay, you might be right, but that's sort of like we spend that money and we can't claw it back, but but you think that they should still focus on this sort of discrepancy of between actual requirements and what they think they need. So any thoughts on that? Maybe Suresh, you could go first from Equinix.
Yeah, there's a lot in the question there. I'm just going to talk from a data center perspective, and others can address the grid level. See, when you design a data center, you make some assumptions, and you project a customer profile and a load profile, etc. And the tendency has been that people tend to look at what is the current situation, but a data center as an asset is 20 or 30 years life cycle product. People don't really have all the information. Nobody on this planet has the on the idea of what is going to be required within the cabinets, the servers, and the switches, etc. So the assumptions are made based on current trends, and you make some assumptions on density, and then you design around that. And if you change, if you want to be very flexible and say, 10 years from now, I can be double or triple the density, and what is that I want to provision, it gets very expensive. So it's really a question of the CapEx as a limiting constraint. So you really have to make judgment on what to expect. So it is like a freeway. It gets very congested in the morning and the evenings when people are commuting. The rest of the time you see there's nobody there, right? But the data centers are really like that. You're provisioning for the peak. Fortunately, for many co-location data center companies, the peak and the average do not vary that much. But the problem is the trends. And also what happens if you design for a particular density and then you start filling the data center with people, and you typically tend to turn down people who want much higher densities because it adds cost as a non-recurring cost to facilitate that. So you end up approving everybody who is below or at the density you designed for, and that drops the overall average power density that is being consumed, in addition to the block-based topology. So you end up with a lot of power being stranded and the space being used up. So what happens later on, none of the new customers come in with lower densities. They're all coming in at much higher densities. All of a sudden, your data center is becoming obsolete because you don't have the ability to cool, you don't have the space. It becomes a problem where you cannot accommodate the newer users. I think, let me stop so the problem of predictability of what is going to go in the data center and the problem of how you allocate and accept customers in, and how do you position them. All of these are very complex problems.
Okay, interesting. I suspect, Ed, Rish, you might have something to add. Ed, do you have a view on that?
Yeah, I mean, what Suresh said is completely true. There is a strong argument to say, and I think in your question, Dan, you were kind of alluding to why does it matter? Well, in one way it doesn't, because if the customers have paid for their contracted capacity, then from a P&L point of view, it's all good. The real issue generally is not so much about the P&L, provided the contracted capacity is being paid for. The real issue is, despite paying for it, there is all of this unused infrastructure, and it just seems terribly wasteful. And I think that's fundamentally what this is about. And if nothing else, in pure embodied carbon, we're not going to talk much today about sustainability, but just think about the amount of carbon that is being used unnecessarily, you could argue, in provisioning infrastructure that's never going to be used. So it's mainly a financial thing, but there's also a sustainability question around this as well.
That's an excellent point.
Yeah, those are great points, Bruce. From my side, I would say over provisioning, I can understand from the data center perspective, right? It's basically a risk-averse method if you're looking from that mindset. But at the same time, if you look at the two very important elements of any operations, one is the speed. You want to make sure that the data centers can operate nimble in a speedy manner, and to a great extent, data centers are designed to do that. And second is lower the cost. While over-provisioning may be looked as a capital expenses, we don't realize it is also an operating expense. That hits you on your bottom line every time. But the other part of that is looking at the connected versus the demand load. A lot of time connected load is what is the over-provisioned load, but the demand may be 50% of that or 60% of that. So you're paying that 50% cost of operation all the time, and that's quite significant. And also looking from the grid needs. So when you're over-provisioning, grid is designed for the connected load and not just running your transmission and distribution lines, but also looking from having generation plants that are able to support that over-provisioned need from data centers. So when one data center is probably okay, but the minute you start adding 2-3 big data centers, 10, 20, 30 megawatt, it all adds up at the end of the day. So I would say data centers may be looking at that from a more reliable operation perspective, but there are more creative ways you can always look at that allows you to do what you want to do, but at the same time be a little bit more cautious about the cost as well as the carbon footprint.
Mm-hmm. So it seems like what you are alluding to, Rish, is that some or even many operators overpay to the utility because they overestimate maybe, or not overestimate necessarily, but they safeguard themselves, for future requirements, which they end up not using. So they sort of contract for, bigger substations than they need, and, they enter into contracts with utilities, you think, that are sort of, again, like, are unfavorable that way to the operator, because the operator will not be using all that energy. So is that something that you research, observe?
Right, absolutely. I mean, there's a lot of research that goes, utilities have to recover the cost. The grid operators have to recover the cost. And if you put the infrastructure that is for the over-provisioned, need, then of course the costs of the contracts will be billed accordingly based on the infrastructure cost recovery that one has to make. It might be a few cents that may, not really hit you when you pay monthly, but over years, like as Suresh said, 20 years or 30 years operation period, it's quite significant. And when you start adding a lot more data centers, it's even societal benefits are also quite or other societal impacts in this case are also quite significant.
You know, as I hear this, the conflicting views come into focus. We need really a holistic understanding, right? So yes, data centers over provisioning forces the utilities to spend more on peaking plants, et cetera. It adds to their capital and operating expenses, which get transmitted back to the customers. But the data centers have a problem too. Even if, say, we are forecasting correctly and not over provisioning, the way the data centers are designed inherently lead to stranded capacity. So try to explain, it's not just the source that you need to worry about. You need to worry about the demand that is segmented inside the data center. So each segment, needs to have the distribution associated with it. And sure, you can design a distribution to be sufficient so you can convey the power into the location within the data center. But the data center is also constrained by cooling. Sometimes cooling insufficiency prevents you from utilizing power in an area where power may be available. So the problem is, it's a little complex to make sure that the amount of space you paid for, amount of power you paid for, and amount of network capacity you paid for, et cetera, exactly balancing out 100% is a very difficult thing to achieve. I hope I haven't confused everybody, but it's not just the source, but how you segment the distribution, and then how do you balance each segment of the distribution within the data center. These are challenges.
No, I think balance is a very good word, an important word, and I guess that we can use as a segue to the next sort of question or line of inquiry, which is we so far it seems that based on everything you've said, over provisioning capacity is not it hasn't got a single source for problems. So it's multiple layers across the infrastructure and multiple domains even of engineering disciplines. So then if we look at this complexity and how over provisioning of capacity or mismatch of capacity between supply and demand, how it all builds up. So where do we start? So what do you recommend? People look for changes that they might have not considered in the past. Maybe Ed, you could speak to that.
Sure. Well, I'm not sure we'll get time.
Yeah.
I'm not sure we'll get time to discuss the recently approved patent that we have. But this patent, one of the key elements of it is addressing head-on how to access trapped power and stranded capacity. So I don't know whether I'm going to have time to talk to you about that or not.
I think if you've got like a few minutes to do that. Do you want me to pull up one of your slides, like this one?
Yeah. If you go on, let me cut straight to the chase. Go on a couple of slides, please, Daniel, to the one on inherent redundancy. I think it's probably another couple of slides, not that one.
This one.
Right. Okay. So this is what we've all been talking about. Too much power capacity is wasted as trapped power stranding capacity. It is the scourge of the industry. I think every operator knows this and has been doing their best to try to solve the problem. But when you've got these packets of power, whether stranded in rows or in data halls, or in different ways. So far, there hasn't really been a solution to address this. So what some organizations do is they oversell, which is, of course, a commercial decision, by which I mean what they will do is say they had, I don't know, let's say 20 megawatt data center IT capacity. They may end up saying, well, look, our utilization is never going to be above, let's say, 70% maximum, and probably much less. So we'll oversell. And that practice is becoming increasingly common. I won't challenge that. But what I would say is if you're not overselling and you're trying to deal with the problem head on, there is a way around it. If you go to the next slide, please, Daniel. So it turns out that we can use this track power as redundant power if you can access it. Now, my slides are not going to show you how you access. It says patent pending, but the patent has now been approved by the USPTO. And basically, there's a simple rule of thumb. It looks complicated. It's really not. It says that if you operate a system at a certain utilization level, with a certain configuration, you will have a threshold of inherent redundant power, which if you can access it, can replace your redundant components, because we haven't really talked about that. I mean, we've talked about undercapacity, over provisioning, but we haven't also talked about the additional impact of the redundant components that exist in pretty much all data centers to some extent or another. So what this basically is saying is that if you have let's talk about UPS for a minute. Let's say you had a system, let's keep it simple, a small data center, say 6 megawatts with 6 1 megawatt UPSs, okay? So that is N, 6. And if you wanted +1 redundancy, so lambda is 1, then the maximum utilization of that system aggregated is 83.3%. And what that means is that as long as that system operates under 83.3%, you will have N+1 redundancy. If it's a full module system and it was +1 redundancy, the maximum utilization would be 75%. What I'm not going to show you here today, because I didn't really think we were going to get into the weeds on this, but now I think perhaps I should have, is how we do that. But we really believe this is the way forward. So it's basically a way of accessing what is otherwise trapped capacity, diverting it, and using that to replace your redundant components or augment them. Another element of the patent is the adaptable redundancy, which allows you to have multiple SLA lineups in the same data pool, but I won't mention that. So that's one way. And the other big way, of course, of addressing over-provisioning is to actually use the excess energy, which I know Rish is going to talk to you about. So I won't discuss that.
Thank you. Thank you. So before, we discussed Rish's proposal. Excuse me. So maybe just to interpret what you just said as using my own words. So what you're proposing. And I'm not an engineer, so if I understand it correctly, then I'm fairly sure the audience will be able to. So what you're proposing is that you take not a static view or statically scheduled view of the service level the facility provides in a homogeneous manner, but what you're proposing is a more granular approach to what service level guarantees. Maybe not individual systems, but probably cabinets or rows of cabinets received, right? So that's the way.
Daniel, sorry, if I interrupt you, it doesn't affect the SLAs at all. Or what this is, okay. I should have put another drawing up for you guys to see it. But principally, no, it doesn't affect the SLAs. What it basically is saying is we use the headroom, okay, of the system as virtual redundancy. Redundancy. So instead of having your +1 or +2 or whatever it is, that can disappear because you have it anyway by virtue of your utilization level. It's just how do you access it, and that's kind of the secret sauce of the patent.
Okay.
It's not secret.
Well, then I need to spend some more time on studying it, because that's what I thought it was, a form of software-defined power where you can define.
Right. Yeah. There are two different things. That is what you do within a particular segment area, whether it's a cabinet or a row of cabinets, and then what do you do with the redundancies? Slightly different things, but perhaps we can go to the overall slide that kind of talks about the various levels. Yeah. That kind of helps you. So, in terms of power balancing opportunities, you can think in terms of what can you do within the servers, and then next step of many servers make up a cabinet. What do you do in the cabinet? Yeah. And many cabinets make up a cage or a pod, which in turn, contribute to building up a data hall, which in turn, gives rise to the data center and then a campus, then to grid. The servers themselves, usually, unless you're a hyperscaler or somebody that actually has access to the ability to control and throttle the performance of the CPU in terms of the frequency, and you balance based on that. Many of the data center operators don't have access to that. Basically that access to the servers is not available. Servers are sacrosanct. You don't touch it, and they consume whatever they want to do. The servers typically operate at 40% utilization, and it could rise to a little higher number, but it is not accessible to most data center operators. And then the same thing happens with the cabinets, and then you begin to have some level of control through various means. So if you look at the cabinets, you can have battery energy storage available, software-defined power elements that can be used. Once again, right now, these are all just beginning to happen. Not to people are actually using it right now, but they are being tested. Software-defined power becomes really valuable also at the cage or the pod level or the individual customer level. And then the oversell is what being talked about. It's fairly commonly practiced. Software-defined power means of controlling and providing balance is possible. Once again, it's an emerging area, but overselling is fairly common. And then, as you get to the data center level and campus level, these are the kind of things that Rich would focus on. Really, you can provide the energy storage at the data center level. You can have a micro data center that has a grid positive interaction with the grid. So you consume when grid has excess renewable power, you go on the grid, and then when the grid lacks that, you can generate your own micro grid power, and even possibly even feedback to the grid. You can also have storage in various forms. The campus level, once again, it's a micro grid is certainly applicable there. And at the data center level, you have ability to tether smaller edge or micro data centers that can use the stranded power upstream of the UPS. So, and the grid, and I'll let Rish talk about it. So there are various levels of addressing the imbalance depending on where you are. But really, fundamentally, the problem starts at the atom of this whole system, right, which is the server. That is not consuming a constant power. And so you look at your system holistically and address the imbalance at various levels through various means.
So may I just quickly ask before we turn to Rish, so Suresh, so at Equinix, what sort of tools your customers are looking for from Equinix, or you see them using to address that, the atomic building block, or at least the cabinet level? Do you see changes? Have you seen change in the past few years, them adopting like these tools or better tools?
It depends on the sophistication of the customer. You see a typical customer only using a portion of their capacity, because they tend to ask for connected load, and we provision them, and then we charge them on the basis of the provisioning of the power, not the actual use. It depends on the market. It's either metered power, provision power, depending on the locations, etc. But the sophisticated customers who kind of know the use patterns, if you go and look at their power profile, they are consuming 98% of what we allocate to them. So because they know how to manage their loads, and we provide smart tools for them to view instantaneously in real time what is the situation in their cages in terms of power consumption and cooling and temperatures and humidity, et cetera. So they have the tools, and more and more people are becoming more sophisticated, and they're reducing the imbalance. But once again, it depends on the customer, the level of sophistication they have internal to their organization.
Okay, that makes sense. Rish, over to you. I know that there is something, that you want to propose as part of this, a bigger solution from electrical power research. So, would you care to discuss that for?
Absolutely, Daniel. I think again, some great inputs early on. If you can move to a slide that shows the wedge, the green and blue slide that provides a kind of a framework. So when we say, where do we want to start? And the question I ask for myself is, where do I want to start, right, on this topic? I believe the next one, Daniel. So where do I want to start? This one, please. Yeah, thank you. So if you look at this is a framework, right? This framework, I continue to leverage this at my Electric Power Research Institute, but was developed during my work at Lawrence Berkeley National Laboratory, which is, where do you want to start as a data center? The first and the foremost you want to start is operate your data center as efficient as possible, right? So if you look at the historical trends of the power usage effectiveness, or PUE, we have come from 2+ PUE now to almost 1 point something PUE, right? Or even lower than 1.1 PUE. What does it tell us? It tells us a couple of stories. One is data centers are doing a great job on improving energy efficiency, which is basically getting the same level of service, but trying to use as less energy as possible to get that service. The second thing it does tell us is a lot of improvements have happened on the infrastructure side of things, specifically with the cooling side. There's a tremendous opportunity that is available on the IT infrastructure side of things, what you saw in the previous slide with respect to the servers, whether those are servers for computing, servers for storage, etc. So there's a tremendous potential to look at there. So I would say, engage your utility at a very early stages to evaluate what are some of the ways that you can look at. And that is where, when we start going right of this wedge, as you can see, is interaction with the electric utility, electric grid operator becomes a lot more sense. In fact, this framework was designed and developed during the times when the grid power was extremely congested during peak afternoons, what we call peak summer afternoons. And this is, was done in 2008, almost 13 years ago. But this is becoming even more relevant as you move towards the right side of the wedge, where you kind of provide resources back to the grid, and where there's an increasing need of interaction with the grid operators and communications infrastructure, specifically with variable renewables, right? The more variable renewables you have and the intermittency you have with the variable renewables, I think that becomes more and more relevant in terms of how data centers can dynamically manage some power management options. The second aspect of it is we look from all the way down to the server, all the way up to the campus and down to the grid. There's also a regional aspect in between that kind of is subtly missed. A lot of times in the past, we used to have a system load, what we call, as a problem. And then we used to find ways to really manage that system load and dispatch everybody that is within that system. That could be, a specific zone or specific substation. But now we are getting into that regional specific challenges where the demand, the supply challenges could be very regional. So looking from a regional perspective is also very critical. So I would say, review these options of what you can do energy efficiency and what more can you do in terms of more dynamic options that can be used to support not only lowering your over provisioning, but also adding more value streams and potential benefits in your operational expenses and lowering it as much as possible.
Mm-hmm. Very good. So, okay, so I think we've covered a lot of ground discussing, and maybe for the time being, let me just go back to this slide. So, addressing, various points of the infrastructure, various layers of the infrastructure. So we've discussed the need to get, the capacity planning right for the servers and the cabinets. We've discussed the need to be better and more dynamic with using the capacity currently stranded and dedicated to redundancy solely. Correct me if I'm wrong with that, and maybe also deploying some software-defined power as part of that. And now Rishi described how operators can take a structured approach to think power about power more holistically for the footprint, and make decisions that optimize their cost through demand response schemes. So yeah, that's pretty much covers the entire range of layers, or all the layers. But one question, as an analyst and a research, market researcher, I keep going back to, and that's sort of like one of the testing questions or test questions I've got in the back of my mind whenever I research any area, really, not just power or over provisioning, is that what is it that we need for people to change behavior. So basically that's I understand it's a difficult one and a big question, but what do you gentlemen think is needed for the market to again change behavior and start looking at these options you've highlighted today, and be maybe a bit more ambitious and more more aggressive in their optimization of their infrastructure. So do you have any thoughts on that?
All right, I can answer some of that.
Yeah.
So in terms of demand side response, Rich has a good roundup, good summary. I think the elephant in the room is that very few, hardly any data center organizations are actively participating in a demand-side response, and it's a win-win. If and when it happens, it's going to be great for everybody. It's going to be great for the grid by providing grid support. It's going to be good for the data center operators because it's going to create new revenue opportunities, but it's just not happening. So, and there are good reasons why it's not happening, and we need to overcome those hurdles. There's a lot of concern. There's a multifaceted problem, but just to give you a clue about what two of the main problems are. One is the understandable concern that operators have regarding system integrity and interaction with the grid and what that would do to system integrity. It's a concern. It's not something that they've done in the past, but it's it is an issue. And then this next bit varies globally and mentally around the world. Is the grids themselves? If it's been written about in numerous academic papers how the grids themselves can benefit from data centers operating as microgrids. But the grids themselves need to change. They need to enable data centers to operate in such a way that they don't impact system integrity, but are able to hook up to the grid, whether that's through operating in island mode or exporting to grid, whether it's spinning reserve. If you think about all this underutilized capacity, why couldn't that just be, for the most part, under certain circumstances, just be exported to the grid? And then we've got fixed frequency response and all of these other things that a data center could and should be doing in the interacting with the grid, but it's not happening. So that's the fundamental problem. If we want to say under provisioning, if you put the pattern aside for 1 minute, which is one way of dealing with it, then the next thing is, right, what are we going to do in terms of how are we going to move things along in terms of demand side response? Is it not happening?
And I agree with that. There are different people trying to do the same thing. There are different people with their own IP. But from a physical setup, right, there are a lot of opportunities. Data centers provide resiliency through diesel generators backing up 100% of the power. It's really stranded capex. If you think about it, diesel gens, they are operating less than 1% of the total time. So you're spending millions of dollars on an asset that is sitting. So why not convert that into something that is producing power all the time and using putting the capex to use? And if you're going to do that, why use diesel? Because it's going to be not acceptable anyway in the future. So go to an acceptable alternative that can potentially transition to, in the future, perhaps even hydrogen, right? So you have an idea about on-site generation to interact with the grid. Certainly, my company is looking at that. So it's no longer the same taboo that we're not going to interact with the grid and be grid positive. And the other thing is storage. How do you incorporate storage at various levels, at the cabinet level or the data hall level, or even large-scale battery energy storage at the campus level? So those are possible. And in the future, there are other energy storage possibilities exist. Maybe it's too soon to talk about them, but in general, I agree that everybody needs to work together to balance the supply and the demand. And you'll see more openness from data centers to collaborate with the grid.
So, Daniel, real quick, so on my side, if you could just quickly go to the slide 17, please, the one after the last one you showed. I think, the behaviors, of course, are the most difficult to change, right? Because behaviors have been built within a specific purpose and a specific reason. And if you want to look at behaviors from a survival mode versus a thriving mode. So when we look at, the behaviors that might be changing is the value and the benefits of some of the recommendations or some of the challenges that we know from our provisioning and how there are solutions already to do that could be addressed. I think that aspect of demonstrating it and showing it is a very critical element, and that's what we've been doing for the last 10 years. At least the things that I have spoken, these are not something that are out of academic research. These are based on data. These are based on real field tests and real experiences of working with data center operators, owners, technology vendors, electric utilities, etc. So what can be done in terms of behavior changes we'll start looking into is, there are best practices that have been developed and there are technologies, and some of the panelists here mentioned about those technologies in terms of what could be done in terms of dynamic power management, cooling, management, etc., that can be used to effectively integrate, demand response best practices. And I should always be careful when I speak to the data center community. DR is demand response in our world and not disaster recovery, right? Which is in the data center world. So we are talking about demand response. There are some ways you could do that. And second one is, I always emphasize is you're not just helping data centers by doing so, lowering your cost and improving your operations, but also looking into improving electric system reliability and resilience and reducing the overall cost, which also benefits the data centers. And also third one, which is gaining a little momentum, and this is research we did with at EPRI with Federal Energy Management Program, DOE's program, FEMP, as well as with Lawrence Berkeley National Laboratory, Dale Sauter there, is into looking into improving local resilience. And I think this is a very critical aspect and new concept that we need to start thinking about. If you are able to really embark upon some of these best practices when the grid power is constrained, you are lowering the amount of infrastructure that is needed to over-provision all the time, so that you're kind of running at maybe 60% utilization rate or 80% server utilization rate for a few hours a year, 87, 60 hours, but not all the time. So you're improving local resilience and improving if you're using energy storage, as Suresh mentioned, and preferably, going into the renewables and not so much on the fossil-based systems. Then all of a sudden you can lower your sizing of your energy storage capacity that allows you to use the same energy storage for a longer time span for local resilience as well. So I think it is very critical to start thinking about these very different strategies and innovative approaches that data centers can do. And we are at the cusp of where humans are going on space and, managing servers in a dynamic way to allow, the drivers that make our provisioning go away or improve reliability should be possible.
Yeah, let me just add one thing before we all drop off for next meetings. In terms of managing the servers, it's certainly open to enterprises and hyperscalers who actually have their own metal. And for companies like Equinix, unless we have started offering our own bare metal services, Equinix Metal, so we'll have the availability of that option. But for most co-location data centers, whether it's a retail or wholesale, they don't have access to that. But apart from that, I totally agree with everything that Rich said.
A very final question because unfortunately we are running out of time. So it's a very simple one. So there's a word that is lurking in the back of my head. So we are talking over provisioning today, which as we agreed on. Creates, first of all, a cost issue, CapEx, OpEx, also sustainability. And when it's out of balance, then it can also create, the frustration that even if you've got, capacity in some shape or form somewhere, you still can't, deploy. So from your point of view, and maybe just, a few words, each of you, do you think, as an industry, as individual operators, we can strive for oversubscription for capacity across the layers, and instead of looking at stranded capacity and how to deploy it, we would be actively managing the load, starting from individual servers and all the way up to dynamically managing the entire data center load? Is that, you think, an ambition we can have or should have even?
No, we have that ambition, and we're beginning to take the first steps toward it. And on that note, I have to drop off. But certainly, all that we talked about today here makes sense, and companies like Equinix will actively participate in whatever makes sense.
Thank you. Thank you, Suresh. Ed, final words?
No, I really don't have anything to add at this stage, Daniel. Thank you.
Thank you, Ed.
So my side, I think everybody said great. I have said everything that I could say. Only comment I would add on to that is, I can completely understand data centers' perspective for over-provisioning, but needs to really understand the drivers. And there's also potential that you could have redundancy in network and not redundancy locally as well. So I think it's very important to start looking at that and how, we can work creatively to improve, the conditions of the over provisioning, as well as continue to operate more reliably.
Great, fantastic. Thank you very much, everyone. And with that, I'm handing it back to Chris.
Yeah. Thank you very much, Daniel, and thanks to all the panelists for taking the time to share all the different perspectives you have on this issue of over-provisioning. You can rate the session now on your screen because that's just about all we got time for, but please do give your feedback. It's really helpful and very much appreciated. And the next session we have, which is up at 9 a.m. EDT, is a presentation from our partners at Legrand, where Calvin Nicholson will be presenting on remote monitoring for the edge, including smart PDUs. You can join that session with me in just a minute. I'm going to hop across and intro that. So it'll be good to see you there. Take care and thank you for viewing.
Thank you, Chris. Thank you, everyone.